Okay, and you actually find online 2 tutorials or 3 tutorials that do exactly this thing with exactly the same data that you can go through step by step. If you go to support tutorials, you find those to the very end, because it's been a while that I wrote them. There are 3 tutorials that go through not just the quality check-in, they actually go the entire way. Quality check-in, LiDAR pre-processing, and finally derivative production. While I'm at it, there's also a great place to learn about LAStools. That's this user forum here. It's a very active user forum with over 2,000 people. And pretty much everything that can be asked about LAStools has been asked at one point, and usually also answered. And if you're on the social medias, there's also a Facebook page. That's more for the fun side of LAStools. That's here where I post interesting things, like a really cool animation of a 3D tree that was scanned with LiDAR. It has a really good soundtrack too. You should check it out, but we're not doing that right now. Yeah, that's here, for example, this the user forum. And if you then have a question, for like a last ground error, then you get everything that was said before about an error with last ground, and you can read a few of those, and then most likely your question will be answered already. And if it doesn't, then you can just send a question there and somebody will answer it, me or some other user of LAStools. So LASoverlap, that's the tool that before made that beautiful image. That's a nice thing to run after receiving a large amount of LiDAR flight lines. Area 0, strips raw. In here there are 7 strips. Now I could go and double click each one of them. Or I can use a wildcard. A wildcard means anything matching this, for example LDR, anything matching this file name with the star can take as a joker role will be added. So if I press add, it will add all 7 of them. So then that's a nice thing to have if there are 479 tiles in flight lines in that folder. And now you see why I only see the boxes, because that allows me very quickly to load large amounts of LiDAR. This is still fairly small, but for the purposes of this demo it's big enough. One thing you can do is very quickly inspect what is inside the file by just using the arrow keys to walk up and down. And as you can see, there's some information printed here. This information you also get with a tool called LASinfo. It's a bit of a boring tool for demonstration purposes because it just prints a text file with the contents. But you also see the contents here. For example, you see the number of points in every file, and you see the bounding box of every file. And you see that the files have no projection information. So LASoverlap, you don't really need to change anything in most cases. It just does the right thing, except maybe specifies the output. I want the output to go let me see. I want the output to go in the directory right next to where the strips raw is. So I say use current, and I give it a name. I call it overlap.png, and then I say run. Oh no, I don't say run, because I know the projection of these files, and I'm creating an image now. And if I know the projection, I can just add it. So it can produce a KML file. Only when it has projection information it can produce a KML file. So I can just add it here. I say it's UTM zone 19, and I hope I remember that correctly. And if I now say run, I have LASoverlap is running, but now we have more than one input file. We have a whole list of files, and you can see which files will be used. They're in this list. The files are flight lines. We will check the elevation. We check for the lowest elevation. We create the overlap image. We store it in this directory, and we add UTM-19N so we can create a PNG. We can create a KML file to look at the PNG within Google Earth. So what happens now is all the 7 flight lines are loaded. Each one is considered to be a flight line, and it looks for the overlap between these flight lines in the entire area for the 7 flight lines and colors it with different colors depending on how much overlap there is. It also looks at if there's a difference in the lowest elevation of every 2 by 2 meter cell, because that's what was specified here. Check within 2 by 2 meter cells. That's the default. I didn't change that. Instead of color coding it, you can also output the actual values. Then you create counter grids. I now created images to look at, but you can also generate rasters with a value like 5. This area is, for 1 pixel. That would mean this area is covered by 5 flight lines. Or you can output the difference as an actual number. And the difference here is 0.17 meters. Right now I just output a color coding of the difference. And let's have a look what we created. They are right here. And let's go straight to the KML visualization and see if I did that right. Yes, that looks correct, because that's an airport in I don't know exactly where. So here you see now the overlap that was computed, and very easy, very intuitive. You now see how these 7 flight lines overlap. Is that what you wanted? Well, that depends on what you wanted. So I don't know, but this gives you the information to decide that. The other thing is the check for alignment. That is the difference file. And you get the difference file only in areas where you have an overlap. That's why blue means 1 flight line. So there's no overlap between flight lines. It's just 1 flight line covering that. But wherever you have a different color, like this azure or the yellow, there you can compute the difference between the flight lines, and here it's color coded with red or blue, meaning half a meter difference. But you see these differences mainly occur in forested areas, and we didn't ground classify these are raw flight lines, so we don't know what's forest, what's on the ground. It just uses a lowest point. But sometimes there is no lowest point on the ground in one flight line, but there is a lowest point on the ground in the other one. So then you get these you get these very high differences. Important, especially for an airport, is that you have mostly white in the open areas. Now again, these visual representations, that's a quick quality check. If you actually want to do a real quality check, then you need to look at the distribution of errors across the overlap areas, and you can do this by outputting the actual values and not just the coloring of them. But this is very useful because you can just run this for the entire county, and then you look at it, and if there's one flight line hanging 20 meters above all other flight lines, you instantly see it. And that's something that happens quite often because it has not enough support in the flight line alignment calculation. Some little adjustment file was not, some checkbox wasn't checked in the processing or something like this. So this lets you very quickly validate that it's all more or less aligned. The other thing that people like to do is control point checks, and there is a tool for that in LAStools. It's called LAScontrol. And if we look at LAScontrol. Oh, by the way, a good idea is always to close tools when you're done using them, so you don't have too many open. LAScontrol right here. So again, I'm browsing to the same area and I'm loading all the strips by just saying add them all. And what happened? Looks like my strips have the chicken pox. Suddenly we have all these red dots here, and that is because this file name happens to be the file name I'm always using. And it looks, if it finds that file name in the folder, it automatically loads the control points. And in this case, the control points are organized in a comma-separated value file, which is typically the case. And it has some kind of string saying what kind of control point it is, and then X, Y, Z. And that's, you need to tell LAStools how to interpret each of the lines in the control file. So the first one we can't understand. So S means skip it, and then X, Y, Z. Control points, I don't know, maybe I should quickly talk about it. Control points are given to you by the surveyor, or you ask a surveyor to go out in the field to get them. They are exact locations you really know are the truths. They are quite expensive because this is not to obtain, because there's a lot of manual labor required of very skilled personnel. But you want to use them to check your LiDAR against them, so you know your LiDAR is actually at the right spot and delivers the right elevations everywhere. You don't need to check the LiDAR everywhere, but there are some recommendations how much checking you need to do, and it obviously also is based on the application you're running. With LAStools, the LAScontrol check is really simple. If you have classified data, you can use only the ground points. We don't have classified data right now, so we just say run on all the points. And it basically takes one additional parameter, that's this control point file, and how to parse that control point file. So what it will do, it will go over all these 7 files now and find sufficiently many points around the control points, create a triangulation, and probe the triangulation at the position of the control point, and then compare it against the control point and report the difference. And that is what it's reporting now. Oh yeah. Type easting northing Z. These 4 columns were in the original file. Type was the thing that was skipped because LAStools doesn't know what to do with type. Type is just a text string describing the point. Open, paved, field, 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 forested. And then X, Y, Z. This is the control points that were given by the surveyor. What we now did, we added 2 more columns. The LiDAR Z, that's a Z we compute from the LiDAR, and the difference between the LiDAR Z and the control point. And if you look at the differences, they're very small. 14 centimeters, 1 centimeter, 8 centimeter, 5 centimeters, 6 centimeters. Oh, it looks all good. Oh, here it's suddenly 40 centimeters. Now that's a bit worrisome, but that's in the field. And here it's 17 meters. That's a bit worrisome, but it's in the forested area. And remember, we didn't ground classify our data. We used all the points. So we shouldn't really look at checkpoints that are ground control points that are in the forest. You can also visualize that with LAStools by picking now just some area here. Maybe I'm picking this area here. Now you can also see the control points. There are these red spheres. Here they are. They have a radius of 1 meter. And now you can see the ground control points inside the LiDAR. And if I triangulate my points, Then what I want the triangulation to do, I want it to cut my control point in half. And this basically does it perfectly here. So the surface defined, that's exactly what LAScontrol computes. It computes the surface based on a triangulation and then compares the Z value at this surface with this one. And this is one of those that has just a few centimeters or even just a few millimeters difference. And it's in the runway. By the way, we talked about this yesterday. You see the intensity isn't corrected correctly here. You see the strips on the runway, which are more reflective than the rest of the runway, is actually visible as something that's taller, slightly taller. Actually, if I turn on the intensity, you should see that in the intensity of the points. There you go. Along these super, reflective strips on the airport, they actually come up as several centimeters. But this is a very old survey here. That's very old data. So this is probably in one of those that are in the field, and then somewhere here I think there's a control point hiding. How can you possibly find it? Well, you can use the wireframe mode. And who spots the control point? There is somewhere there. So, of course, for this control point, there's no, if we don't ground classify this, there's no point in using this measurement because it's going to be some interpolation across some tree. All right, there we go. Here's my canopy model that was going on in the background. Let me load that now into ArcGIS. You may have to help me here. What? I think there's another window open somewhere. Oh yeah, this one. All right, success, cleanup. Script was completed, took 5 minutes. Close. And now I should be able to do it. Now I can drag and drop it in here. Somewhere here maybe. Okay. Now I'm closing this. And now you need to help me again because I need to go and say something like here. I always forget what to do. Properties, and I have to go here and say now. How is that? Oh yeah, that's stretch it. Oh, the stretch, yeah. Min max. Oh, minimum maximum. Yes. Then apply. Is that it? Ah, yeah, there we go. And then OK. And then maximize it. Ooh. No, I shouldn't maximize here. I should maximize. I don't know how to zoom in ArcGIS. Is that zoom?
Well, it shows it works.
Here's the zoom, yeah. Let's zoom in a little bit. There you go. All right. I showed you 3 different ways of using LAStools now. I could show you 4, so that's a batch script, but come to me if you want to see that working. And there are many more LAStools, and I pointed you to tutorials. I walked you through the entire pipeline on these 7 strips that you are now so familiar with already. And if you want to read up on the tanks in the Polish forest, go to my blog and just search for tanks, or search for bunkers because there's a follow-up story about bunkers. All right, and thank you very much.